And hello everyone. Hello everyone. Okay, this video we are going to continue talk about what the elastic collision. Okay, and last time in 1D elastic collision, okay, we derived the equation. Or suppose we have 1D collision and you have initial velocity of these two objects, v1 and v2, and we derive the equation for the velocity after the collision, v1 prime and v2 prime. Okay, and we also obtain the feature equation of the 1D elastic collision. This means one is related to the relative velocity, okay, before and after the collision. And then from the equation we have, we just make a little more discussion, okay, because we want to let you know this equation really okay really coincide with the experimental observation because in the class I show you very small three clips, three videos. Okay, when um three video. In this three video, in one case, the mass of the object is the same, and the other two video is the collision between the light car hit a heavy car, and then the final one is heavy car hit a light car, and and I want to show you. Okay, experimental observation is the same as the equation we derive here. Okay, so and then when for discussion, we just make the case much simpler. Okay, suppose, we assume right now, we assume, okay, if before the collision, V1 is equal to V and V2 is equal to 0. Okay, that means before the collision, okay, M2 is at the rest. Okay, and M1 is moving. Okay, and okay, if we assume this initial condition and what's the what is the velocity after collision? Okay, v1 prime. Okay, we just put this condition this initial condition in this equation. Okay, very easy. Okay, nothing magic here. So v1 prime. Okay, so because v2 is 0, so this term must be 0. Okay, so we don't have. Oh, sorry, we don't have to take. We can ignore them. We just focus on the first term, m1 plus m2 and v. And what's the v2 prime? Okay, after collision. Okay, what's v2 prime? So v2 is 0, so it's m1 plus m2 to m1v. Okay, and we just we have three situations because we have three videos on the Moodle, right? Okay, the first situation is what if m1 is equal to m2? Okay, mass is the same. Okay, the two object mass is the same. Okay, and what will happen? Okay, m1 is equal to m2, so v1 prime will equal to, so m1 is equal to m2, so it's 0, right? Okay, so what's a v2 prime? Okay, so m1 is equal to m2, so it's because m1 is to m1 and v, and cancel out, so it's equal to v. And you will see when the m mass 1 and mass 2 are equal, mass 1 mass 2 are equal, they just before collision, after collision, you just exchange the velocity. Okay, exchange velocity. That's the feature for when the mass you have when your the two object have the same mass. Before after collision, it just exchange the velocity. Okay, so before the collision, v1 is v, v2 is 0. Okay, but after collision, v1 prime becomes 0 and v2 prime becomes v. Just exchange the velocity. Very interesting. And you have when your object has two objects have the same mass. This will happen on elastic collision. Okay, so there's the first situation, and I think yeah, there's a video demonstrate this exchange the velocity. And the next one is okay, which first? Let's see which one first. M1. Okay, so okay, so that situation M1 greater than M2. Okay, M1 greater than M2. Okay, that's that's for correspond to the video that the heavy car hit the light car. So heavy car hits light car. Okay, in that video, I want to observe what's the velocity direction after the collision. Okay, so we see. Okay, okay. So let's write down the velocity after collision. Mm-hmm. Actually, it's the same. Nothing magic. It's b1 prime. Okay, b2 prime is equal to m1 plus m2 m1 minus m2 to m1 to m1. Okay, and times what's that? Yeah, times b. Okay, okay. So let's see. All right, when a heavy car hit a light car, okay, so what I want to see is this term is greater than zero, okay? And this term, of course, is all positive, so this term is greater than zero, okay? So after the collision, collision, okay, the two cars move in the same direction, and all to the right in the same direction. Okay, okay, and they both moving to the right. Okay, so that's when the heavy car hits a light car. Okay, should we have discussed about the extreme condition? Okay, let's see, extreme condition. Okay, extreme condition. Let me see. Do we have discussed extreme condition? To be car. Okay, let's discuss the extreme condition. Okay, so I think some textbook discuss extreme conditions. Okay, so if we have extreme conditions, for example, right now M1 is greater than M2. If M1 is much greater than M2, okay, what will happen? So M1 greater than M2, that means okay, B1 prime is equal to M1 plus M2, M1 minus M2, MV. So because M1 is greater than M2, that means M2 is not important anymore. So this will become V. So what about the V2 prime? Okay, so 2m1, m1 plus m2, and the same because m1 is much greater than m2, so m2 is not important anymore. So this will give you the 2v. Okay. Okay, so when this situation happen, that means okay, we see the result here. Oh, okay. Okay, don't forget the initial velocity of v1 is v, and v2 is equal to zero. Okay, so in a very extreme condition, when a very sudden, this very similar to when a car hit a man. Okay, because the mass of the car is much greater than the man. Okay, so when the car hit a man, you see the velocity of the car doesn't change doesn't change that much because v okay, before collision v, after collision still v. But for the light object or light car or man, okay, before collision is velocity is zero. After collision, okay, it will become two the velocity, double the velocity. Okay, double the velocity. So that's why we need a speed limit. We need a speed limit. The speed limit for the car because you see when the car hit the man, okay, the man will have the double velocity after collision. Okay, that will create a lot of damage. Okay, Okay, so that's one situation. Okay, M1 greater than M2. Okay, so another final situation, what if the M1 is smaller than M2? M1 is smaller than M2. Okay, that means when a light car hit a heavy car. Okay, okay, what will happen here? So V1 prime equal to M1 plus M2. M1 minus M2V. Yeah, just the same thing. Okay, M1. Okay, so when M1 is smaller than M2, so okay, I want to observe here. Okay, I want to observe if M1 is smaller than M2, so the V1 prime will smaller than 0. And the V2 prime, yeah, everything is positive, so this is greater than 0. So that means after collision, the two car move in. After collision, the two cars, okay, the two cars in move in reverse direction, in opposite direction, moving opposite direction, opposite direction. Okay, because very from this formula it's very clear. Okay, after the collision is smaller than 0, so it's moving in this way. Okay, and B1 moving this way after collision, and B2 moving in this way after collision. So the direction are opposite. Okay, and in the video, when the light car hit the heavy car, yeah, that's true. In the video, when the light car hit the heavy car, and after the collision, it move in reverse direction. This is the same prediction from this very simple model. Okay, okay, this is a very simple model. Yeah, from using kinetic energy conservation and momentum conservation, we can predict the velocity after collision. And this really works. Okay, it really works. Okay, an experiment can demonstrate this point. Okay, this formula really works. Okay, so when a light car hit a heavy car after collision, they move in reverse direction, or no, reverse in opposite directions. Direction. This is okay. So, and then finally, do we have discussed the extreme condition? Extreme condition. Okay, let's see. Extreme condition is not difficult. Okay, extreme condition if M1 is very, very small compared to M2. Okay, and what will happen? What will happen? Let's see. V1 price equal to M1 plus M2, M1 plus M2 V, and V2 prime is equal to M1 plus M2 2M1 V. Okay, if M1 is very, very small compared to M2, what will happen? Because that means M2 is much greater than M1. So that means it's not important anymore. So, so this will become, V1, V1 prime is equal to minus V. Yeah, just 40 bounce back. Just 40 bounce back. And the velocity just it's the same as initial velocity, but it's reverse direction. Okay, so what will be V2 prime? If M1 is very smaller than M2, that means M2 is greater than M1. So that means this term is not important anymore. And M2 is greater than M1, so this term will become close to 0. Let's say M2 to M1. Be M2 is greater than M1, so this is going to be 0. So it's 0. So in a very extreme condition, okay, the M1 and light one just reverse, hit a very heavy object, just reverse, moving in reverse direction. And M2 just doesn't move. Makes sense, right? With a very light object hit a very heavy object. The light object after collision, just move in reverse direction, and a very heavy object doesn't move anymore. So this equation, okay, also demonstrates this point. Okay, and it fits the common sense. Okay. Okay, so this is discussion about the result of one big collision, and the next video we'll do a little check about the center of the motion of center of mass. Okay, and that will be very easy check. Okay, but we'll demonstrate that in the next video. Okay, see you in the next video. Bye bye. 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 Do close this.